Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Indina Mastira, and today I would like to explain and analyzing the merge sort using work and span. So what is parallel merge sort? It is a divide and conquer algorithm that sorts an array by dividing it two halves and sorting each half in parallel, merging the sorted half in parallel. Okay, so work. What is work? Work refers to the total number of operations the algorithm performs. At each level of recursion, the algorithm performs a merge operation and on all elements. Since the array is divided in half, at each level there are log n levels. Each level does BON work, emerging all elements. Alright, next we go to the span, which is T infinity. Span is the longest sequence of dependent operations, the critical part. Assuming unlimited processor, the left and right recursive calls are done in parallel, so only the time of one side counts. Merging two sorted arrays and size n can be done in big O log n time using a parallel merge algorithm. The recursion has log n levels, therefore total span T infinity equals to big O log n. So the example question is given an input array of size n equals to 8, analyze the work and span of a parallel merge sort. Shows the calculation for the total work and span. So for work, which is T1, T1 equals to big O and log n. So equals to big O 8 log 8 and big O 8 times 3 and equals to big O 24. So the total work for n equals to 8 is big O 24. For the span calculation, T infinity equals to big O log n equals to big O log 8 and equals to big O 3. So the total span for n equals to 8 is big O 3.
Hi, my name is Muhammad Naim. So next, I would like to continue about the relate the analysis to Amdahl's law and performance. So what is Amdahl's law? Amdahl's law is the predicts the theoretical speed up of a task based on the fraction that can be parallelized. So here we can see the formula of speed up, which is s equal to 1 divided by 1 minus p plus p over n. So we have three different variables, which is s, p, and n. So s is the theoretical speed up, p is the parallelizable fraction, and n is the number of processes. Before I go to key insight, I would like to explain a little bit about the serial fraction. So serial fraction is the term which is 1 minus p represent the portion of the algorithm that must be executed serially. So what key insight said that speed up is limited by serial fraction, which is 1 minus p. So as the number of processes increase, the impact of the serial portions become more significant. So what's the implication of Amdahl's law is when the number of processes increase, the speed up is limited by the serial portion, serial fraction of the program. Next, I would like to talk about the application of merge sort. So what is merge sort? Merge sort is a classic example of a divide and conquer algorithm that can be effectively parallelized. So merge sort have two side arrays, which is parallelizable portion and serial portion. The first one, parallelizable portion, is the division and sorting of the side arrays can be done in parallel, while the serial fraction is the merging step, however, can be more challenging to parallelize effectively. So here we show you one example. If 70% of merge sort can be parallelized, which is p equal to 0.7, and using different processes. So we can see here, if we have one processes, the speed up will be 1, but if we have two processes, the speed up will be 1.54, which is the calculation of speed up will be different. So the speed up calculation is 1 divided by 0.3 plus 0.7 over 2. So we will get the answer. So here basically the speed up will be different. That depends on the how many processes that you have entered. The last one is about span. Span limits speed ups even if most of the algorithm is parallel. Span affects the parallel execution time, which is t infinite equal to span equal to order log base n. But the actual speed up is the word over span or equal order of log n base n over order of log base n or equal to order n. So here we will use the example question from previous slide. As you guys can see here, we want to calculate the parallelism for n, so we just entered the total work for n and total span for n, and then we will get the parallelism for n, which is 8. So I think that's all from us. Thank you.